All right, today let's use our programming skills to generate our own STL files. Yes, the same files you used for 3D printing. Let's go. So to save anything as a particular file format, the first thing to do is to understand what that file format is, how it's described. So I've just gone and searched in Wikipedia for STL file format. You can do the same thing. And it pulls up this document which describes what the ASC2 STL file format looks like. We often say this ASCII as an ASCII. That's how we pronounce that. ASCII STL. So this means an STL file that's written with basic characters and text symbols. So looking at this file, we can see that the file begins with a line that says solid space and then a name, and that it also ends, the document has to end with the line nsolid space name. So what I'm going to do is I'm going to try to write some code that's going to print this information first just to the screen, not yet to a file. I'm going to print it to the screen so I can see that it's working, and after I get it working, I'll print everything to a file. All right, so let's go to our code window. Okay, so in our code window, I have the F stream included because I'll need that later. But I'm going to call my solid test. You can give it any name you want. So remember, the first line had to say solid space test, and the last line had to say nsolid. So I've got those two cout statements in my file. Okay, now let's look at the next part. So we'll say this is done, and this is done. Now if you click back on the Wikipedia page, the next thing the file has is it stores lots of triangles. So your solid object is made of lots of these triangles, which are called face T. So I think of it as face triangle for face T, but you also could just say facet. I'm not sure what the correct pronunciation is. So you have to type, for every triangle that you're going to store, you have to type face T space normal and then 3 numbers, which we can just set as 0, 0, 0. And then at the end, we have to do an end face T. So let's go to our file and make sure we've got that. Okay, so we do face T normal 0, 0, 0. Done. And then at the end, we have to end the face T. Okay, great. Next, we type outer loop, and after we're done the outer loop, we have to type end loop. But notice this has been tabbed over. Okay, so that's been moved over by a tab. So on our code, we have to type outer loop, and the \T is what provides the tab. So \T, then outer loop will tab that over. Of course, the /n just puts a return character at the end. I could have done that up here. Instead of the end line, I could have put a /n at the end of that up there. Okay, so this is now done. I did the end loop statement here with the /t. The /t means, yep, you got it, tab. So this line is done. And finally, the last lines for me to work on are the 3 lines that define where the 3 coordinates of the triangle are going to be. So if I go back to the STL file, I have to type vertex and then the 3 coordinates, and then vertex and then the next 3 coordinates, then vertex and the next 3 coordinates. The order of these vertexes does matter. It defines whether that face is going to be a facing in or facing out. But we'll worry about that more later. So first, let me just pick any 3 coordinates for a triangle. So I'll pick 0, 0, 0 as one point, 0, 1, 0 as a second point, and 1, 1, 1 as a third point. So we can then save it, and then compile it and run it. And this should print to your screen the one ASCII STL